Welcome to this comprehensive guide on file I/O handling and persistent storage in Visual Studio and Unity 3D, tailored specifically for beginners. Today, we'll explore the fundamental concepts of reading and writing data to files, and how to implement robust data persistence within your Unity 3D projects using C# in Visual Studio. First, let's dive into file I/O fundamentals in Visual Studio using C#. File I/O, or input-output, involves the crucial process of reading data from and writing data to files on a computer storage. Think of a file as a stream of bytes, a continuous flow of information passing through a communication path whenever it's open for reading or writing. C# provides several essential classes for managing file operations. The file class offers static methods for creating, copying, deleting, moving, opening, and closing files. StreamReader is used for reading text line by line from a file, while StreamWriter is dedicated to writing text to a file. For binary data, Binary Reader reads primitive data types from a binary stream, and Binary Writer writes them. The directory class helps manage folders, and FileInfo provides properties for file manipulation. To read from a file, you first include the system.io namespace. Then, create a StreamReader object, passing the file name to its constructor. Use readLine to read one line at a time, which returns null when the end of the file is reached. Alternatively, the endOfStream property can detect the file's conclusion. Crucially, always ensure proper disposal of the StreamReader object using a using statement, which guarantees the file is automatically closed, preventing resource leaks. Writing to a file follows a similar pattern. Include system.io, then create a StreamWriter object with the file name. Utilize write or writeLine methods to output your data. Just like with StreamReader, a using statement is vital for StreamWriter to ensure proper disposal and file closure. Beyond reading and writing, C# offers basic file operations like file.createText to create new files and file.appendText to add content without overwriting existing data. You can also file, delete to remove files and file, exist to check if a file is present, providing robust control over your file system. Let's look at a quick example. This C# code snippet demonstrates both writing hello, file IO, and this is a new line, to example.txt, then reading and printing its contents. For optimal performance, read and write files in large chunks, minimizing frequent seek operations to reduce overhead. Also, reduce the frequency of opening and closing files, and utilize buffering mechanisms like BufferedStream to significantly improve I/O performance. Always check file operation calls for errors to ensure robustness, and be mindful of platform-specific newline characters, which can vary between operating systems. Now, let's transition to persistent storage in Unity 3D, which refers to the crucial ability to store and retrieve data across different game sessions. Unity offers several methods for data persistence, each suited for different needs: player prefs, serialization, and external storage solutions. Player prefs is a simple way to store and retrieve key-value pairs, ideal for user preferences or non-critical data like volume settings or high scores. Data is stored in the local registry or system-specific storage without encryption, supporting int, float, and string data types. However, it's not suitable for complex or sensitive information. To store data with player prefs, use playerprefs.setInt, setFloat, and setString. Always call player prefs save to commit these preferences to disk. For retrieving data, use getin, getFloat, and getString. Serialization is the process of converting complex data structures into a format that can be easily stored and reconstructed later. JSON, or JavaScript Object Notation, is a lightweight, human-readable data interchange format. Unity's JSON utility class simplifies serializing and deserializing JSON data. First, create a serializable class, like GameData, marked with System, Serializable, to define your data structure. Then, serialize your object using JSON utility.toJSON to convert it into a JSON string. Save this JSON string to a file using file.writeAllText, typically in application.persistentdatapath. To deserialize, read the JSON string from the file using file.readAllText, then convert it back into an object with JSON utility from JSON GameData. Binary serialization converts objects into a stream of bytes, offering more security and speed than JSON, though the files are not human readable. Similar to JSON, mark your class with system serializable. Then, create a binary formatter and a file stream to handle the binary data. Serialize the object using formatter, serialize, and remember to close the file stream with file, close. For deserialization, open the file stream with file, open, and use formatter, deserialize, to cast the data back to your object type. Player prefs is simple and easy for small data, but lacks encryption and complexity support. JSON is human readable and platform independent, but less secure and potentially slower for large data sets. Binary serialization offers greater security and efficiency, though its output is not human readable, making it ideal for complex and sensitive data. Choose player prefs for simple settings, JSON serialization for moderately complex, human readable data, and binary serialization for complex data requiring security and efficiency. Ensure data persists throughout an application session using Don't Destroy on Load for game objects that hold your data. Implement static classes, singletons, or static variables to manage and access your persistent data consistently across your game. Always consider encrypting sensitive data or saving it to protect user information and game integrity. Handle complex data types carefully when using JSON utility, as it might require custom converters for intricate structures. Finally, always use application.persistentdatapath to get the correct, platform-independent path for storing your game data, ensuring compatibility across devices. This comprehensive overview equips you with the foundational knowledge to effectively handle file I/O and persistent storage in Visual Studio and Unity 3D. By applying these concepts and best practices, you can build robust and reliable data management systems for your games and applications. Thank you for joining us. We hope this tutorial empowers you to create amazing experiences with persistent data.